I do have a linear combination of sine of x and cosine of x in the denominator's position. So I do think that suggests a Weierstrass substitution will be the appropriate choice. But you remember what that says about sine of x? It says it can be interpreted this way. Cosine of x can be interpreted this way. Dx can be interpreted this way. Now I'm cleaning up. Well, very much like my rationalizing substitution to get rid of those radicals, it transformed the integrand into a nice rational expression for which PFD most likely will apply unless it's easy to just differentiate off the top of your head. But here too, with this Weierstrass substitution, it's doing something very similar. It's transforming the integrand into something that's just a nice, clean, rational expression. So I don't know, everybody. You can stop watching if you want. I shouldn't really finish this because you already committed to partial fraction decomposition plenty of times. But this might be interesting. So if you don't mind, I am going to finish. PFD, partial fraction decomposition. So here, no calculus. Let's get rid of fractions. How interesting. Notice in this example, I don't have any nice clean linear factors for which I can allow t to be that number. Now, I could create 4 different equations by making up numbers out of thin air for t 4 different times. But let's see if I can be a bit more sophisticated. Let's see if I can just, how about equate coefficients of t cubed? T squared. T. And constants. So the last equation says B and D are the same. There's the only other D I see. I'll consider it to be the same as B. Do you see I'm avoiding Gauss-Jordan elimination on augmented matrix, as well as inverse matrices, as well as Cramer's rule? So next on my list, how about just taking the first and third equations, combine them? How about if I subtract the third from the first? If I subtract the third from the first, is that going to give me this? And my second is this. Now, multiplying the first by maybe -2, adding to the second. So, looks to me that I'm committing to partial fraction decomposition. My A is 4/3. My B, if you look at this relationship right here, my B is -1/2 of A. My C is the additive inverse of A. And didn't I have that my D was equal to B, I think? Do you mind if I stall? I just think I'm writing too small. So can I just copy what I have, just write it bigger? Not changing anything. Well, we can certainly anti-differentiate this off the top of our heads. As well as this. Notice how if u is this denominator, du is 2t plus 1. The constant is half the coefficient of t. Here's a coefficient of t upstairs. I'll make sure that's half of it, but it already is. So for free, can't that be evaluated as this? And lastly, back substituting. Actually, you know what? I didn't notice this. I can combine these two terms quite easily, can't I? The first and the third terms. Let me do just that. And lastly, let's go ahead and back substitute. Now, it is indeed the case that I've run out of room. So do you mind if I do a little bit of hand waving? With my eraser, I've got the composition of two inverse functions. They cancel each other out. And lastly, that fraction can be nicely reduced. Wow, that was a mouthful.